Hello, now that you are an expert at pulling out the greatest common factor, we're going to do a little more factoring. So please turn to lesson 15. We're going to factor by grouping. All right, take a look at grouping. All right, we're going to have trinomials. That's 3 terms. And so we're going to try to factor out what they have in common and do it by grouping. I'd like you to give it a try. I know there's other ways to solve it, but just for today, trust me, because I've taught this so many times, try it this way, and then when we get to easier problems, you might have a shortcut that might be a little easier or different, and that's fine. But for today, let's give this a try. All right, so down here, it says Juan found a pattern for factoring that works for all types of trinomials. Here's the beginning of his work. So I'm going to zoom in at A. We have this trinomial, y equals x squared plus 8x plus 5. He started looking for multiples of 15. All right. And how he got that was that is the A term of 1 times the C term. There you go. He got the 15 from A times C. And then the middle term is our B term. All right, so I have A, B, and C. Okay, so over here he kind of listed all the factors of 15 he could have. All right, let's look at the next one. All right, he noticed, oh, by the way, sorry, he said, let's find some multiples of 15 that add to 8. So that's why he circled 3 times 5. 3 times 5 adds to 8 but multiplies to 15. All right, let's look at B. So the multiples of A times C is negative 6. All right, that's A times C. And then the 5 is the B term right here. Okay, so multiples of negative 6, he just listed them all out here. And then he found, oh, look, let's use this one. Negative 1 times 6 equals negative 6, but if you add them, you get a positive 5. So just hang tight. We're going to use those magic numbers. Now, Juan used a box. I'm going to show you, we're going to use an X, all right? But I'm not going to use it with a highlighter. So instead of a box, I like to use an X. It's really handy. I know some of you just list them. There's lots of ways to do it, but let me show you. So in the X, I always put the A times C term up here, and then I put the B term down here. So watch. A times C was 15, and then B was 8. So I go through the factors and think, oh yeah, 3 times 5, multiply to 18, but add to 8. Multiply to 15, add to 8. These are the factors we're going to use. All right, so let's take a look right here at the next page. All right, they kind of show exactly what I just got done explaining. All right, basically what did Juan do at this step? He found the greatest common factor. This is what we're going to do. All right, so we're going to take those numbers from the previous page right here. And these numbers multiply to the A times C, right? But they add up to that 8x. So it's almost like we're going to substitute in. I'm going to write substitute. Substitute these numbers in for the 8x. So if you notice right here, this is what they did. They used the 3x and the 5x instead of 8x. Don't 3 plus 5, 3x and 5x add to 8x? So we're just substituting them in. All right, the 8x became a 3x and a 5x. All right. Now, once we do that, it's like we have 2 different problems. All right. We're going to cut those down the middle. And then don't they have the greatest common factor? They have an x in common right here. And you're left with x plus 3. Over here, they had a 5 in common. Once we factor that out, we have an x plus 3. Look at that. So it's back to the previous lesson, lesson 13. We were just factoring out greatest common factors, right? Okay, let's do this next one. Okay, we're going to find the numbers that multiply to -6 and add to 5. This is how I would do it with a pen. I would make my x. They would multiply to -6 and add to 5. So this is just kind of how, instead of using a box, I would organize it. Oh, I know I need a 2 times 3. That adds to 5. But it doesn't multiply to a -6, so I can't do that. So I would try maybe 6 and 1. 6 times 1, not going to add to 5. But how about if I make, How about if I make this a negative? Look at that. That multiplies to -6 and adds to a positive 5. So my 5x, I'm going to replace with a 6x and a -1x. Look at here. I just put them right here and here. All right, and then I just zoom down the middle. All right, cut those in half. Look at that. And then I can factor the greatest common factor. I'm going to pull out the greatest common factors that each side has. All right. Okay, so let's continue with the same problem from Juan's problem from A. Now, it says, what is Juan's final equation for each problem? So I'm going to look at this, and it's almost like I have two different problems, don't I? And what do they both have in common? Oh, they both have an x plus 3. Can't I pull out that greatest common factor, the x plus 3? And then what's left over? There's an x left over here and a positive 5 here. Ta-da! That is now in factored form. The greatest common factor on this part was the x plus 3 that we factored out. Let's try 3b. Woo! And if you're saying, this is insane, Miss Shaw, don't worry. I will be back next class and we'll practice it. It's okay. All right, what do they both have in common? They have a 3x minus 1 in common. What's left when we factor that out? A positive x and a positive 2. That is factored form. Woo! Don't worry, we're going to do this a few more times until you feel good about it. All right, let's look at this. Use a generic rectangle to factor each one of Juan's equations. So if I go back up to that x squared plus 8x plus 15. All right, I want this to equal x squared plus 8x plus 15. So there's my x squared and my 15. I need this diagonal to add up to 8x. So let's take a look. I'm thinking instead of 2 and 4, that doesn't really help me. I'm going to try the 3 and 5. So this would be an x by x. I need 3 times 5 to equal this 15. Let's see if this works. 3x, and that would be 5x. Look at that. We did it correctly. Dun, da, da, da. That factors to x plus 3 and x plus 5, which is what we got this way too. See, we're showing you so many ways to get the same answer. All right, let's do this one. All right, this has to have an x in it, an x, but I'm guessing I need a 3 somewhere, so I'll put the 3 here. It's all right. What multiplies to a -2? Well, probably a 2 and a -1, or a 1 and a -2. Let's see if that works. All right, a -1 times x is -1x. 3x times 2 is 6x. If I add those up, is that going to give me that problem way up at the top? 3x squared plus 5x minus 2. Look at that. It works. So the factors are 3x minus 1 and x plus 2, which, once again, we got that direction also. All right, we're going to put it all together now. I'm going to walk you through how to do it. I'm probably not going to do the area box method, but I wanted to show it to you. Okay, let's take a look at number 5. All right, first thing I know, the a term is 1, so a times 10 is 10, and I want it to add to 7. So please try making an x right here. Just give it a try a few times until you're like, I kind of like this. All right, so up here, they have to multiply to 10, and they're going to add to 7. So what multiplies to 10? It's either 2 and 5 or 1 and 10, but adds to 7? Oh, that has to be 2 and 5. These are my factors. I'm going to use these factors instead of the 7x. So I'm going to rewrite my problem. Y equals x squared, and then I'm going to substitute in this 2x and 5x plus 10. See, these add up to this 7x right there? Okay. And then I'm going to cut this into 2 parts. See? That's my lightsaber. I know. If I was in person, I'd be waving around my lightsaber in class. Here we go. Cut that down the middle. Zoom. Feel like a lightsaber. There you go. Be a little faster. All right. What does the left-hand side have in common? They both have an x. I'm left with an x plus 2. On the right-hand side, they both have a 5 in common. If I factor out a 5, I'd be left with x plus 2. Oh, look at this. This is what we did on 3a and b. If you do it correctly, these will always match every time. What I love about this is you know if you've done it right or wrong. At this point, you know I did it right. So I'm going to factor out an x plus 2. And what's remaining goes in the next one. X and a positive 5. Ta-da! Look at that. That is factored. We did it. It's not too bad. Let's try number 6. All right. So first things first, these multiply to 4. I want them to add to 5. So I'm going to make my x. Please try an x. Come on. Multiplies to 4, adds to 5. Okay, that's just too easy. It's got to be 1 times 4. Do you agree? Yep, those are our factors. So don't forget, we're going to rewrite this equation, y equals 4x squared, but blank, blank, and then plus 1. All right, we're going to plug in these factors right here instead of 5x. So I have a 1x and a 4x. Those are both positive. There you go. All right, what comes next? That's right. Down the middle. There we go. All right. We're just going right down the middle. Then on each side, what do they have in common? Let's see. This side, they both have an x. So I'm left with a 4x plus 1. On this side, oh my gosh, they have nothing. What do I do? Well, you know what? They do have a 1. I know that's pretty weak, right? But we're going to factor out a positive 1. We'd be left with 4x plus 1. Look at that. Remember, I promised you if we did it right, these would match. That's right. Factor out the 4x plus 1. They both have that in common. And your leftover is x plus 1. Ta-da! We did it! Come on! That's really good. All right, go ahead and try 7 and 8. And I know you're new at this, so please fill in each step. All right, this should be a 6. This should be 20. They need to add to 5, and this one's going to add to 12. So let's try making our x's. It's going to add to 6 and 20. This one adds to 5. This one adds to 12. Go ahead and find your factors and give it a try. All right, you should have ended up with 3 and 2. Rewrite the problem, 3x squared plus... Now, you can put the 2 first or the 3 first. I like to put them where they're going to have something in common. So if I put the 3x here, they'll both have a 3 in common. Look at that. And don't forget, what comes next? That's right, lightsaber time. Down the middle. They both have a 3x in common. I'm left with x plus 1. This one has a 2 in common. I'm left with x plus 1. Oh, look at that. Ta-da! We know we did it right. Factor out the x plus 1, and you're left with 3x plus 2. Ta-da! All right, do the last one on your own. If you do it correctly, it should factor to x plus 2 and 5x plus 2. All right, let's go to the next page. All right, I'm going to show you number 9. It's kind of important. This one is the same as everything else, except it's got this 2 out here. All right, don't panic on the 2. All right, just like when we had a negative out there, we just kind of leave it out there. Okay, so I'm just gonna put it over here. Here it is. Okay, I'm still gonna do my x. I know it multiplies to 4 and has to add to 4. All right, so I'm gonna factor this and just leave that 2 out there. Okay, so what factors 2 times 2? Yep, that's going to work for both of them. So here I go. I've got the 2 there. Then I'm going to write x squared plus 2x plus 2x plus 4. See that? I just substituted those in. All right, what do we do next? That's right. Okay, so it's like we have this right over here. Okay, we're just leaving that 2 off to the side. All right, I'm going to draw a line down the middle. I have x that I can pull out on this side of 2. Oh, look at that. They match. I know I did it right. And I realize we still have this 2 hanging out here. I haven't forgot about it. So I'm going to pull out the x plus 2. I'm left with x plus, oh, look at that, another x plus 2. And guess what? Now I can bring down that 2, and that's our final answer. So that 2 just kind of hangs out there. Okay. All right, you did a great job. The only thing I would want to show you on number 10 is, watch out down here. Melissa said you don't have to factor out the GCF right away. That is true. See how they distributed that 2? Melissa did right here. Melissa took this 2 that we left outside and she distributed it. I think that's how you say that. And that's fine, except watch out. I don't like to do that because so many students forget this part. Do you notice 2x plus 4 can still be factored? Yeah. So a lot of times people make that mistake and they forget that that can still be factored. All right. So you can still pull out a 2 and be left with x plus 2. So we're going to get the same answer if you do it correctly. But I would not recommend distributing that 2 and making the problem more difficult, because then you just have to factor it back out at the end. All right. You are all set. Whew. You did it. For homework, you're just going to practice a few of them. Please practice using the little X that we did. So here's your homework right here. Let's go. Oh my gosh. I need to show you number 16. Oh man, this is kind of important. You want to know why we're doing this whole thing? Watch this. This is standard form. This is how you go to factored form. All right, we already did this on the previous page. It's x plus 3 and x plus 5. That's why this book taught you factored form. From factored forms, we can get the x-intercepts. All right, you just set each one equal to 0. Y equals 0 when it crosses the x-axis, right? So we're going to get something comma 0, something comma 0. You do that by setting these equal to 0. X plus 3 equals 0. Take the 3 to the other side, it'd become negative. X plus 5 equals 0. Take the 5 to the other side, it'd become negative. I already know that the y-intercept is 15, so that's 0, comma 15. All right, and oh my gosh, I don't know. What's my vertex? Ah, well, you could graph it. You could also use this on your standard form, couldn't we? X equals a negative b over 2 times a. So my line of symmetry is a negative 4. So I know that's negative 4. We could plug that in. Let's take a look when we graph it. All right, this is putting it all together. So my x-intercepts are negative 3 and negative 5. Negative 3 and negative 5. Should probably zoom in. I know that my y-intercept is 15, way up here. I know my axis of symmetry is x equals negative 4. Look at that. I don't know why I'm not on the line. All right. I need a vertex still, don't I? I do. So let's go back up here. Let's try to get that negative 4. Don't I already know that x equals -4, right? X equals -4 on my vertex. It's got to be on this line somewhere. So let's plug in -4 right here. I know how much you hate plugging in numbers. Let's do it right in here. What's -4 times -4? Isn't that 16? Yeah. 8 times -4 is -32 plus 15. Look at that. Wouldn't you get -1? Doesn't that equal -1? That's our y. Look, -1. Now we have a vertex. Let's go back down. -4, -1. Ta-da! If you wanted more points, you can always do a table. There you go. That is why we have gone to all this effort to learn to factor and get factored for. Okay, now we're really done. Great job, everybody.